let's start with the third part of the BigQuery. Now try to understand what is the architecture of BigQuery. So Google's BigQuery was released in general availability in 2011 and is a Google Cloud's enterprise data warehouse designed for business agility. Its serverless architecture allows us to operate at scale and speed to provide incredibility fast SQL analytics over large data sets. Since its inception, numerous features and improvements have been made to improve performance, security, reliability, and making it easier for users to discover insights. Data warehouse drive business decisions. A data warehouse consolidates data from disparate sources and performs analytics on the aggregated data to add value into business operations by providing insights. Data warehouse are the custodians of the most important business data in the enterprise for the last 2 decades. As enterprises are increasingly become data driven, data warehouses play an increasingly critical role in their digital transformation journey. As per Gartner, data warehouses often form the foundation of enterprises' analytics strategy. Data warehouse use cases have gone beyond traditional operational reporting. Today, enterprises need to have a 360-degree view of their businesses. Data is valuable as cost of storage and data processing reduce. Enterprises want to process, store, and analyze all relevant data sets, both internal and external to their organization. So the value of data is increasing by the requirements of the organization. Be situationally aware of any of and responsive to real-time business events. Enterprises need to gain insights from real-time events and not wait for days or weeks to analyze data. The data warehouse needs to reflect the present state of businesses at all times. Reduce time to insights. Enterprises need to get up the running fast without waiting days or months or for hardware or software to be installed or configured. Make insights available to business users to enable data driven decisions making across the enterprise. In order to embrace a data driven culture, enterprises need to democratize access to data, secure their data, and govern its use. Data needs to be secure and accessible to the right stakeholders inside and outside the enterprise. As enterprises look to expand their usage of the traditional data warehouses with growing data volumes, they face tremendous challenges as their cost continues to spiral out of control due to higher TCO, that is total cost of ownership. Traditional data warehouses are not designed to handle the explosive growth in the data and certainly not built for emerging data processing patterns. BigQuery, Cloud Data Warehouse. Cloud BigQuery was designed as a cloud native data warehouse. It was built to address the needs of data driven organizations in a cloud first world. BigQuery is GCP's serverless, highly scalable, and cost effective cloud data warehouse. It allows the user fast queries at petabyte scale using the processing power of Google's infrastructure. Because there is no infrastructure for customers to manage, they can focus on uncovering meaningful insights using familiar SQL without the need for a database administrator. It's also economical because they pay only for the processing and storage they use. Big BigQuery ensures data-driven decision making, which is the need of the day. So BigQuery is the process of making decisions based on the data and not on intuition. Human intuition or observations tends to be biased and provides false conclusions. Sometimes data driven decision making ensures that this is the data from which the conclusion is to be made, as it results in free error free judgment. In order to conduct the process, we must follow these steps. Business problem formulation. It is necessary that you identify the correct business questions before going down the journey. It acts as a priority and provides clarity to the goals. It can also be formulated based on your company's customer needs, maximizing profits, identifying potential customers, etc. In this scenario, to redeem a company is interested in identifying and categorizing restaurants and hotels based on revenue per user. It helps to segment the restaurant and hotels, and they can come up with the right strategy to maximize their earnings. Identify data sources and variables to capture. Once the business problem is formulated, the next step is to identify the sources of data and the mechanism to integrate it with the and store it in a single place. For example, data can come from CSV files, log files, web forms, marketing campaigns, etc. etc. It is also necessary to identify the necessary variables which are the key to the problems. In this case, redeem is capturing the relevant variable revenue, number of users, check-in, customers, and user details. This data is captured from the app whenever they use check-ins, and then it is saved in the Google BigQuery table. The image below gives details of BigQuery table. Like you can see here, all the details, that is the revenue, query, share, etc. These are the options available, and then under this, the heads are schema, details, preview, and below again there are rows, customer ID, months, revenue, and number of users. So depending on all these details, you can get the what are the kind of revenues that one can expect. So all these types of results you can achieve with the help of this BigQuery table. Data cleaning and organization. Before querying and generating insights, it is important to ensure that the data is clean. The error arises due to various reasons. For example, manual errors during data entry, encoding and decoding errors, etc. etc. Apart from the cleaning, it is important to organize your data. It means creating data dictionary that explains all the variables. Here you can see the description of variables given below. You can see again some details about the schema of your database. Then querying the BigQuery. BigQuery provides SQL like syntax to query the table. We can do aggregation on columns, can join tables, and so do many more tasks. BigQuery is ultra fast and can fetch results within seconds. Here we can see that they are selecting the sums of revenue from the revenue table. So again you can see how the SQL query is written. Insights. This is the final step towards our data driven life cycle. Insights are the key to our final business decisions. For example, users are clicking on a particular item more than others. This can help us provide a recommendation of other products which resemble very high to this particular item. This decision made after the insight is helpful to increase sales. Understanding the BigQuery architecture. BigQuery is Google's cloud-based data warehouse system. It is serverless architecture, separated computing from storage. It means storage and computing power can be scaled up to independently. This architecture provides user flexibility and control in terms of storage and cost respectively. Users don't worry about the underlying structure as the Google Cloud manages everything. It helps users to focus on business problems without any technical expertise in databases. Data is stored in Google Cloud distributed file system which is highly reliable and automatically scales up as per the load. Users can even through BigQuery clients, Web UI, REST API, CLI and client-side languages. Data is queried from the storage and then it goes into the compute part where all the aggregation and calculations are carried out. Google's highly reliable network connects the two parts, that is storage and compute. BigQuery structure. A traditional database structure is like a database which with the tables and columns. Similarly, BigQuery follows a structure. Project is a top level container and is like a database in a traditional database system. In order to create its login in the GCP account, you can use the sandbox for free. After login, click the new project, enter the project name and create. Dataset. As there are different departments within the company, you can have different purposes. A project can have more than one data set. Tables. The tables are the columnar presentation of the data. A data set can have more than one table. In our case, Redeem, project name Redeem Analytics. Data set is Analytics, and again, this kind of a screen you can see on opening it. Use cases of customer segmentation. Customers are very important to any organization. As a business, we uniquely fulfill our customers' needs, generating revenue and profits. Customers' needs vary from one to another, and it is part of the segmentation process is to group similar customers in the same group. Redeem is a cashback company that provides cashback to users of restaurants and hotels. The company generates revenue from restaurants, hotels by providing customers with them. It is essential to identify which customers are getting more check-ins, which helps to strategize a new pricing policy also. Business problem formulation. How to know the customers, restaurant, hotels to whom we are providing very good business and categorize them. Data source. Redeem capturing the app's customer and revenue data, then inserting it into BigQuery table. We have two tables, customers and revenue. Let's have a look and do some exploratory data analysis in the BigQuery. How many customers do we have? Let's count the unique customers. Again, you can write a SQL query for this as it is shown in the screen and then check the results. The query is quite simple. We selected distinct customers from the customer table and we got 1000. Redeem analytics customer, the sequence is project name, dataset, table, etc. Revenue generated by the redeem per user. Restaurant have hotels provide a certain amount of each user check-in. In this scenario, only those users will be taken into account into check-in and upload the bill on the Redeem app. Let's see the revenue table by selecting all the columns. Again, a small query can be written using SQL and then check the outcome, that is the results. We can very easily get all these details by writing a small SQL query. We can see that there are 4 variables: customer ID, months, revenue and number of users. Our variable of interest, revenue, user is not present, but we can create it in the BigQuery table by the formula. Revenue revenue per user, number of users. So again, the same similar type of query can be written in SQL and see the results, query results. So that's how you can keep on making various SQL queries and keep on getting the results as you desire. Thank you.